Hello viewers, welcome to the class of control system. I will be discussing today the topic on concept of feedback, characteristics and effects on control system. Now in the last lecture I have discussed about the basics of control system regarding its looping, the open loop and the closed loop forms, their advantages, disadvantages, the requirements, all about I have discussed in the last lecture. In this lecture, the topic of discussion is the concept of feedback. Now, let us first see what is actually the feedback and why the feedback is necessary to develop a control system, and the final effects on the performance of any system which is under control. So, let us first understand what is feedback. Now, the concept of feedback and it is required for automatic control of any system. Now, what is a feedback in basic terms? We know that when we sample any part of output of any system is taken back to the input side so that it can be merged with the actual input of the system, and they can be compared as well to get certain modified output in the next iteration. So here the definition of basic feedback is if either the output or some part of the output, that means a sample of the output, is returned to the input side and utilized as part of the system input. That means we are sampling a replica, a form from the output of any system and taking it back towards the input side and getting it merged with the input of the system so that the next way of working of the system can be defined, can be explained. Now, so this is the feedback. So that means feedback, to run a feedback in a system, it is having two parts. One is sampling from the output, another is merging or mixing with the input. Now, why feedback? Why feedback is necessary for a control system, to understand the working of a control system? Obviously, it is basically for this automatic control, and the feedback therefore plays an important role in order to improve the performance of control system. So this is the basic idea. We always want, when a system is in a running phase, we always want its improvement. So for the performance improvement, basically this feedback plays an important role. How? It supports the continuous monitoring and control to ensure the system to be operated within its predefined limit. That means when the system is in the running state from the beginning, from the initial stage, some predefined limits are set for the running or the operation of the system, and to get the system always into those limits, this feedback does help, it supports. That means how it supports? It is intended that the system objectives which are to be maintained, are to be reached, are to be accomplished by the use of this feedback, by increasing through the increment of accuracy and reliability in the performance of the system. So the feedback allows the system to correct the errors, compensate for it, and compensate for any other interruptions other than errors, and thereby finally the stability can be maintained. So this is why we can explain the feedback is required for the working of any control system. Now, the feedback components can be charted out in this fashion: the reference input or the command input, the input, the output, the feedback path, the error detector and the controller. So these are the final basic components of any feedback system. That means these are almost essential to understand the working of feedback in any control system. Now, what is a reference input or a command input? Reference input is that it is such an input which is applied to the entire system is called the reference input. That means it is applied as a benchmark, it is applied as an ideation, it is applied as an ideality to the system. That means we always want, the system designer will always want that the final output, final response of the system must always reach, must always catch this reference. That means it will work as a benchmark. Now, what is the input and what is the output? In normal forms, it is the normal system output and the normal system input. That means the input can be alternately called forcing function. So the input can be alternately called forcing function or the excitation function, which transforms the form of the input given into such a form that can be utilized properly by the controller present in the system. So the controller is the main working brain of the control system. It needs some amount of executable form of the input, and that executable form is the actual input of input to the control system, which can be called as a component of the system. Similarly, the output, generally we call the output as the response of any system. Now, the response means how the controller works on the given input is another executable, another presentable form which will be returned by the controller while working on the given input will be called the output of the system, which is another component of the feedback. So therefore, input-output are two essential forms for the controller to get into it and to get out of it. Now, the next important component is the feedback path. Now, feedback path means the feedback is connected through a path. That means the feedback signal can flow through that particular path. It needs a certain path through which the feedback signal should flow, and that is called the feedback path. How it is connected? It is the return way, it is the return path to the summing point. In the next slide, I will be showing the basic block diagram of the feedback. So there, the summing point which is present, the feedback path is the return way to that summing point from the side of the output response. That means the system side, which is showing, which is represented as its response, that will the signal taken from the output side way back to the return way back to the summing point is the feedback path. That means it comprises a feedback component with feedback gain, which sends back the output to the summing point, which can be alternately called error detector. So therefore, the feedback path is very much essential, a very much integral part of any closed loop control system, through which the feedback signal from the output side of the main system or the controller or the process to get it back in its return way towards the error detector or the summing point. The next component of feedback is error detector. It is the most crucial component and most vital component of any feedback control system. The error detector gets a signal from the output response. That means the signal which is returned back to the error detector through the feedback path in the last component is one of the inputs of the error detector, and another input to the error detector is the reference input. So basically, the error detector needs minimum two inputs, one in the form of reference that is given over here, and another in the form of signal coming through this feedback path. So what it does, this error detector, the main role of this error detector is to compare these two signals, the reference input and the feedback path signal, to generate an error which is called actuating signal, and that actuating signal is the driving force to the controller. Now the next, or the last but not the least, and most importantly, the whole working of the control system is dependent on this component, which is utmost crucial for out of all these components, and that is the controller. So the controller while getting the actuating signal as its input from the output of the error detector will generate the control signal to necessarily control the whatever parameters is kept under control. That means in a plant or a process there are many variables or many parameters can be controlled. Out of those parameters, if it is a single variable process or in a multi-variable process, more than one parameters or a single parameters can be controlled via that controller. So getting that actuating signal at its input, the controller will generate the necessary control signal to control one or more than one control parameters into the plant and process for its proper operation, so that ultimately the main objective of the control system is fulfilled. That is, the output response, the overall output response must always follow the reference input, so that ideally the error gets zero. So these are the components of control system.